Hello, Assalamualaikum warahmatullahi wabarakatuh. Good morning all. Welcome to the second meeting of math class with me. Teacher is me. So, as usual, let's start the day with a prayer together. To the lead? Yes? Please lead the prayer for today. Thank you. So, thank you everyone. And for attendance, Risma, who are absentees for today. Okay, no one is absent today. Very good. So all are present. Let's start today's lesson. Are you learning activity sheet 3D? How about your pen and paper? Great! Let's begin a fun and exciting lesson. At the end of the lesson, you are expected to first identify a geometric sequence. Second, find the common ratio. And third, differentiate a geometric sequence from arithmetic sequence. Showing in your screen is the sequence 2, 4, 6, 8, 10, and so on. What type of sequence is? Yes, very good. This is an arithmetic sequence because every term after the first is obtained by adding 2 to its preceding term. You really do master our previous topic of arithmetic sequence. Good job! Now, how about this? 2, 4, 8, 16, and so on. Is this an arithmetic sequence? Let's see the common difference. The second term minus the first term, which is 4 minus 2 is 2. The third term minus the second term, which is 8 minus 4 is 4. And the fourth term minus the third term, which is 16 minus 8 is 8. Obviously, it doesn't have a common difference. Therefore, it is not an arithmetic sequence. So, if it's not an arithmetic sequence, then what is this? Is this what we call geometric sequence? Yes, very good. This is an example of geometric sequence. So, what is geometric sequence? Geometric sequence is a sequence where every term after the first is obtained by multiplying the preceding term by a non-zero constant, called the common ratio, represented by R. Remember the K term here, which is multiply. Geometric sequence is a sequence where every term after the first is obtained by multiplying the preceding term by a non-zero constant, called the common ratio, represented by R. Let's study the previous example. 2, 4, 8, 16, and so on. Every term after the first is obtained by multiplying the previous term by 2. Because 4 is equal to 2 times 2. 8 is equal 4 times 2. And 16 is equal 8 times 2. To here, what we call the common ratio. This R is equal to 2. From here, we can rewrite this multiplication sentence into this. 4 divided by 2 is 2. 8 divided by 2 is 4. And 16 divided by 2 is 8. Is also equals to 2. This is now we get the common ratio, which is 2. Thus, the common ratio can be determined by dividing any term in the sequence by the term that precedes it. Common ratio can be determined by dividing any term in the sequence by the term that precedes it. Next, let us have another example. -1, 5, -25, 125, and so on. Let's compute the common ratio of this geometric sequence. Let's start with the ratio of the second and the first term. So, R is equal a sub 2 divided by a sub 1. Our a sub 2, which is 5, and our a sub 1, which is -1. So, 5 divided by -1 is -5. Next, the ratio of third term and the second term, where R is equal a sub 3 divided by a sub 2. Our a sub 3, which is -25, and our a sub 2 is 5. So, -25 divided by 5 is also equals -5. And last, the common ratio of the fourth term and the third term, where R is equal a sub 4 divided by a sub 3. Our a sub 4, which is 125, and our a sub 3, which is -25. So, 125 divided by -25 is also equals -5. Therefore, the common ratio is -5. Then, we can say that -1, 5, -25, 125, and so on is a geometric sequence. Going back to definition of geometric sequence. Geometric sequence is a sequence where every term after the first is obtained by multiplying the preceding term by a non-zero constant, called the common ratio, represented by R. I emphasize here that the constant or common ratio should be non-zero. Then, what will happen if the common ratio is 0? If the first term is 2 and the common ratio is 0, we form the sequence 2, 0, 0, 0, and so on. But if we divided any term of the sequence by its previous term such that R is equal a sub 2 divided by a sub 1. Our a sub 2, which is 0, divided by our a sub 1, which is 2. So 0 divided by 2 is 0. And R is equal a sub 3 divided by a sub 2. Our a sub 3, which is 0, and our a sub 2, which is 0. So, 0 divided by 0, and this not equals to 0, because it indefinite, and also are not equal 0. Thus, the common ratio should always be non-zero. Next. This time, let us try to determine whether this sequence 80, 40, 20, 10, and so on. Tell whether this sequence is geometric or not. Notice that succeeding term after the first were reduced to half. Then we can predict the common ratio is equal to 1/2. Let us prove it by getting the ratio of each term. So, R is equal a sub 2 divided by a sub 1. Our a sub 2, which is 40, and our a sub 1, which is 80. So, 40 divided by 80 is equal 1/2. Then, R is equal a sub 3 divided by a sub 2. Our a sub 3, which is 20, and our a sub 2, which is 40. So, 20 divided by 40 is also equals 1/2. And R is equal a sub 4 divided by a sub 3. Our a sub 4, which is 10, and our a sub 3, which is 20. So, 10 divided by 20 is also equals 1/2. And since the ratio are equal or common, which is 1/2, then this sequence is geometric sequence. Next, text note. The common ratio or R is positive if the terms of geometric sequence are all positive or all negative. Just like this, the common ratio or R is positive if the terms of the geometric sequence are all positive or all negative. Examples. Number 1. 2, 4, 8, 16, and so on. These all positive. And item number 2, negative 3, negative 9, negative 27, negative 81, and so on is all negative. And item number 3, 48, 24, 12, 6, and so on is all positive. These geometric sequences are positive or all negative. So, the common ratio is positive. Next, take note, the common ratio or R is negative if the geometric sequence have alternating negative and positive terms. The common ratio R is negative if the geometric sequence have alternating negative and positive terms. Examples. Number 1. Negative 1, 5, negative 25, 125, and so on. Item number 2, 10, negative 20, 40, negative 80, and so on. And item number 3, negative 48, 24, negative 12, 16, and so on. These geometric sequences have alternating negative and positive terms. So, the common ratio is negative. Common ratio can also be obtained from the general formula of geometric sequence that a sub n is equal a sub 1 times r to the power n minus 1. Common ratio can also be obtained from the general formula of geometric sequence that a sub n is equal a sub 1 times r to the power n minus 1. This formula is intended to find any term of a geometric sequence. Next, examples number 4. Find r in the geometric sequence with the first term is 24 and the fourth term is 648. And so, as I said, we can get the common ratio using the formula, say for instance. Now, to find common ratio using the formula, a sub n is equal a sub 1 times r to the power of n minus 1. We choose substitute to given value. So, a sub n is a sub 1 times r to the power of n minus 1. We use a sub 4 as a sub n. So, substitute 648 is equal a sub 1, which is 24 times r to the power n minus 1. N is equal to 4 because we use a sub 4, so r to the power 4 minus 1. Then simplify the exponent. So 648 is equal 24r cubed. Divide the dual equation by 24 to isolate r at the right side of the equation. Then 648 divided by 24 is equal 24 divided by 24r cubed. After dividing, the result is 27 is equal r cubed, or r cubed is equal 27. And this is not yet the final answer. Take note, we need the value of r, not r cubed. So, we will write 27 into exponential notation, such that it contains the same or equal exponent with r since. So, 27 is equal to 3 times 3 times 3. So, 27 is equal 3 cubed. Thus, our r cubed is equal 3 cubed. Remember the property of equality of exponential equation that if exponential are equal, then the bases are also equal. So, r is equal 3. R is equal 3. Good job, kids. Next, let me have a question for you. This will further measure your understanding of today's lesson. Find r in the geometric sequence with the first term is 5 and the fifth term is 80. And write the first 5 terms of this geometric sequence. Splendid! You have already learned how to identify a geometric sequence and how find the common ratio of a given geometric sequence. And now, I am hoping that you can also differentiate geometric sequence from arithmetic sequence. That's all for today's lesson. Good job! Thanks for sharing your thoughts and ideas for this lesson. Congratulations for doing your best. See you next time. Assalamualaikum warahmatullahi wabarakatuh.